Hi everyone, today's SOS video is for Unit 8, Lessons 4 and 5. The main concept for today's lesson is systems of equations can be solved algebraically using what we call the elimination method. Remember, the solution to a system is the ordered pair that will make both equations true in the linear system, and to eliminate means we're going to add a variable term with its opposite to form a zero pair, which means we want to find one of the variable terms in each equation that we can get to add to zero so that we can solve for the other. The procedure we're going to use to solve the linear system is as follows. First, we're going to line up the variable terms and the constants in both equations. Decide which variable term, x or y, will be easier to eliminate. In order to eliminate the variable term, we want the coefficients to be additive inverses or opposites of each other so that we can get that zero pair. We're going to add each column to eliminate that desired variable, and the resulting equation will have only one variable. So we're going to solve that simple equation. Once we solve that equation, we're going to substitute the value of the variable into either of the original equations to get the value of the other variable. And then, of course, you're going to check your solution to see if you're right. If your solution doesn't check in one or both of the equations, you know you made a mistake and you can go back and find it. Remember, when the directions say to solve the linear system, the answer is an ordered pair that makes both equations true. All right, let's take a look at the first example. The system of equations is 4x minus 2y equals 12, and negative 4x minus 9y is equal to 54. So our variables and constants are lined up. If you notice here, my x terms are opposites of each other, so that if I add these together, it will be a sum of 0. This is the term here, or the variable that we want to eliminate. So let's do that. So when we add 4x and negative 4x, that gives us a zero pair, so the sum here is 0. Negative 2y plus negative 9y is negative 11y, and 12 plus 54 is 66. Now we're going to solve this simple equation by dividing both sides by negative 11, and we get y is equal to negative 6. Now we're going to take the y equals negative 6, and we can substitute it into either of these equations. Let's just take the top one. So 4x minus 2 times negative 6 is equal to 12. So we substituted this y equals negative 6 in for the y in this equation. And now we're going to solve for x. 4x plus 12 is equal to 12, minus 12 from both sides, and we get 4x is equal to 0. Divide by 4, and we get x is equal to 0. All right, and now we're going to do our check. We're going to check the solution, which we could write as an ordered pair, 0, negative 6. Let's check this ordered pair in both solutions. So here's our check. First, we'll check in 4x minus 2y is equal to 12. 4 times 0 minus 2 times negative 6, is that equal to 12? This is 0 plus 12, which is 12. Both sides are the same, so it checks. And now we'll check in negative 4x minus 9y equals 54. Negative 4 times 0 minus 9 times negative 6, does that equal 54? And we get 0 plus 54. Is that equal to 54? And yes, it is. So this, when x is 0 and y is negative 6, both equations are true. Let's take a look at the next example. So again, for step 1, we want to make sure that we have our variable terms and constants lined up. And then we're going to decide which of the variable terms we want to eliminate. Now, if you look here, you see that in each equation we have a 3y. But if we add these together, we won't be able to eliminate the term because both of these terms are positive. So what we can do is we can use our multiplication property of equality. We can multiply both sides of the top equation by -1. If we do that, we'll get a new equation. Negative x, we'll distribute here, negative x minus 3y is equal to, multiply this side by -1, negative 15. And now we have negative 8x plus 3y is equal to negative 12. Now when we add these two equations together, the y terms will sum to 0. So then we would get negative 9x is equal to negative 27. Divide both sides by -9. We get x is equal to 3. Once we solve for x, we can go back to either of these equations and now solve for y. So let's just take the top equation. X plus 3y is equal to 15. We're going to substitute this in for the x. 3 plus 3y is equal to 15. Subtract 3 from both sides. 3y is equal to 12. Divide both sides by 3, and we get y is equal to 4. So our solution to this equation, this system of equations, is 3, 4. I'm just going to do a quick informal check here. So if I substitute 3 in for x, we get 3 plus 3 times 4. 3 times 4 is 12. 3 plus 12 is 15. It checks in the first equation. Negative 8 times 3 is negative 24. 3 times 4 is 12. Negative 24 plus 12 is negative 12. Checks in our second equation. Okay. All right, let's take a look at the next example. In this example, we have 5x plus 10y is equal to 20, and 9x minus 3y is equal to 15. Well, it doesn't look as easy as the first two examples because we can't see here either of the variable terms having the same coefficient. But again, we can use that multiplication property of equality, and we can look to see if we can eliminate one of the variables by multiplying both equations by different numbers so that we can get one of the variable terms to add to 0 or to be eliminated. So if we look at the x terms, I have 5x here and 9x here. Well, if I multiply the top equation by -9 and I multiply the bottom equation by 5, then when I distribute here, multiply each term by -9, each term in the bottom by +5, the x terms will have coefficients of -45 and +45. So let's do that. If I multiply the top by -9, we'll get -45x minus 90y is equal to -180. Multiply the bottom equation by 5, we get 45x minus 15y is equal to 75. Now we can add the two equations together. The x terms will add to 0, and here we'll get -105 is equal to, when we add here, -105y is equal to -105. And now we just have to solve this little equation, divide both sides by -105, and we get y is equal to 1. Now we're going to substitute y equals 1 into either equation. In the last two examples, we selected the top equation, so let's use the bottom equation to solve for x in this example. So we have 9x minus 3y is equal to 15. We're going to substitute the 1 in for y, so we get 9x minus 3 times 1 is equal to 15. And then we get 9x minus 3 is equal to 15. Add 3 to both sides. We get 9x is equal to 18. Divide both sides by 9. we get x is equal to 2. So the ordered pair, that's the solution to this system, is 2, 1. Okay, let's do our check. Okay, as you can see, our check works. We'll substitute in x equals 2 and y equals 1 in for the x and y in both equations. Both equations are true. Now you might be saying, well, what if I wanted to eliminate the y terms in this system and not the x terms? So again, using the multiplication property of equality, if you want to eliminate the y terms, then you have to think of numbers that you can multiply each equation by so that you can get the y terms to cancel out or get to 0. So maybe you would multiply the top equation by -3 and the bottom equation, or actually multiply the top equation by +3, multiply the bottom equation by 10, and then when you multiply, your new system will be 15x plus 30y equals 60, and 90x minus 30y equals 150. When we add the equations together, the y terms will add to 0. Here we'll get 105x is equal to 210. Divide both sides by 105, and we get x is equal to 2. And then when we go and substitute in to solve for y, you'll see that we get, I'll leave that up to you, you'll see that you get the y equals 1. All right, thanks for tuning in to today's SOS video. I hope you found it helpful, and we'll see you next time.